Hello, and welcome to Lesson 2.7, Using Formulas. Our objective for today is that I can solve equations for specific variables, and I can convert units of measure. Our vocabulary for today, first of all, we have formula. This is an equation that expresses a relationship between certain quantities. Secondly, we have a literal equation. This is a formula or equation that involves more than one variable. And lastly, dimensional analysis or unit analysis. This is the process of performing operations with units. So the first problem that we're going to tackle is how to solve for a specific variable. So in letter A, we are told specifically that we want to solve for x. So what I'm going to do is I'm going to start by highlighting x. That's what we're trying to get by itself. And we're still going to use our SADMEP skills in order to solve this. We start with addition, subtraction, and then we work our way closer and closer to the variable, working our way through division and multiplication, exponents and parentheses if they apply. So in this case, I'm going to start with a dividing line down my equal sign as I have been all unit. And the first thing I see, we have the things that are happening to x. We are multiplying it by 5, and we are subtracting 2y from it. So if we're trying to get x by itself, we need to get rid of that minus 2y, and we also need to get rid of that divided by 5. So the first thing we're going to do is we are going to add 2y to both sides. And that's going to give us 5x. Those cancel out. And we're going to get 2y plus 15. Now, we'll talk about it more later on in the year, but the proper way of writing these kind of things is variables come first and your constants come after that. So 2y plus 15. Now, we're going to divide both sides by 5. Now, we need to distribute this divided by 5 to all of the terms on the right-hand side. Anytime we are doing the division or multiplication steps with solving equations, we need to make sure that we are applying that across all of the terms that are in the equation at the time. This is why we try to do that subtraction step first in order to hopefully knock out some of these terms and get them to go away. All right, so now we get that x is going to be equal to, well, 2y over 5 is 2/5 y, plus 15 divided by 5 is 3. All right, let's take a look at letter B. We are specifying that we want to solve for y. So I have a y right there. Now, we have a 10x and we have a minus 6y. Well, let's think about what's actually happening here, right? We can rewrite minus 6y as plus negative 6y. Right? Now, if we do that, now it becomes a little bit more obvious what's happening here. You have a case where you have 10x being added to negative 6 times y. All right, so that's one way of visualizing this. So the first thing we need to do, since we realize that it's addition there, we're going to subtract 10x from both sides. And we get negative 6y is equal to negative 10x plus 24. So my next step is to then divide both sides by negative 6. And we're going to do that to all three of our terms. So y is going to be equal to negative 10 over negative 6. That can reduce to 5 over 3x plus 24 divided by negative 6 is going to be negative 4. Or if you wrote it as just minus 4, that would be acceptable as well. All right. Letter C, we are trying to solve for y yet again. And so for this one, again, we've got a 2x being added out front. We've got a multiplied by 4. So let's start with the opposites. We're going to do minus 2x from both sides. And when we do that, those cancel, and we're left with 4y is equal to minus 2x plus 12. My next step is to divide everything by 4. And I'm going to get that y is equal to negative 2 over 4 is negative 1/2 x plus 12 divided by 4 is 3. And that's our simplified form. If you were to write it as negative x over 2 plus 3, that would also be an appropriate way of writing this expression. Now, we've got 3 you-try problems that I want you to try on your own. And when you are done, please check your work against mine right here. So letter D, we're asked to solve for y. So again, I'm going to highlight y just to isolate and kind of key in on what I want to do with it. And we start with our dividing line down the equal sign. So I have 3 multiplied by y, and then we're subtracting 9 from that. So the opposite of subtracting 9 is adding 9. All right, so now we're going to get 3x plus 9 is equal to 3y. My second step is going to be to divide by that 3. And again, I need to divide all of our terms in the equation by 3. So our 3 over 3 cancels out, and I'm left with x. 9 divided by 3 is 3, and those 3's cancel out, and I'm left with y. So y is equal to x plus 3. Letter E is again asking us to solve for y. And so we have a y right there. And we're going to start with our dividing line. So we have 5x being subtracted, so I'm going to add 5x to both sides. And we've got 5x plus 4 is equal to 2y. My second step will be divide by 2. So we have 5 halves x plus 2 is equal to y. Okay. Lastly, letter F. We're solving for x, and this is in a little bit different scenario. We've got our x in the numerator, so we're going to start off with our dividing line, and we're going to start the same. We start with SADMEP, so subtraction and addition. So we're going to subtract 15 from both sides, and we've got y minus 15 is equal to x over 3. Multiply both sides by 3, and we need to make sure we distribute that. So we get 3y minus 45 is equal to x. Our 3's canceled out there, right? Okay, so now at the bottom of the page here, you see some common formulas that come up in math class, and many of these are going to come up in science class as well. So you have the perimeter of a rectangle, area of a rectangle, circumference of a circle, area of a circle, and area of a triangle. You should have seen all of those formulas in prior years in 6th or 7th grade math, or maybe even going back into 5th grade. Okay, now the ones on the right, these are going to be science applied formulas that we're going to use at some point during the year for most of them. So distance traveled is the distance is equal to the rate times the time, the speed times time. The density of an object is the mass divided by its volume. The temperature, this is a way to convert to Celsius from Fahrenheit. And so it's 5/9 times the Fahrenheit temperature minus 32. Potential energy, we'll use this a lot at the end of the year in 4th quarter. This is mass times gravity times height above some sort of gravitational body. And then the last one is kinetic energy. That is 1/2 times the mass times the velocity squared. Again, we'll be using that in science towards the end of 4th quarter. So now we're going to go to the next page, and we're going to solve a literal equation for the given variable. Now, these are a little tricky, and for 8th graders, they tend to be frustrating. However, if you were to just sit back and apply SADMEP as we have for every other problem that we've done this year so far, you're going to be able to solve these pretty easily. So we are told we're solving for x. And again, it's helpful to highlight or indicate or underline or do something to identify and pick out that variable that you're searching for. So the first thing I need to do, I see that I have r plus p times x. Well, r plus, the opposite of that is going to be minus r. And when we get that, we have negative t minus r is equal to px. We're still trying to get that x by itself. So our next step is going to be to divide everything by p. So we divide each term by P. And what are we going to get? We're going to get negative T over P minus R over P, and that's going to be equal to X. So it was still just a two-step equation. We didn't really have to do anything all that fancy with it, but it got us a little bit different of a response. So letter B, we're told we need to solve this equation for M. This is Newton's second law of motion, which states that force is equal to the mass times the acceleration of an object. Again, a formula we're going to be using in science and manipulating in exactly this way. So if we're trying to get M by itself, it's being multiplied by A, so we need to divide both sides by A. And you get force over acceleration is equal to the mass. Okay. Now, we're going to go on to 2 you-try problems. I want you to try them on your own and then come back and check your work against mine. So letter C, we have an equation that is in standard form. We'll learn more about that as the year goes on. But what you need to know right now is we are solving it for x. So we're trying to get x by itself. So I'm going to again highlight the x. My first thing that I see is that we are adding by to it. So I'm going to subtract by from both sides. And we get, and that's by, not x. And so we get that to cancel, and we have ax is equal to c minus by. My next step, we're still solving for x, so I'm going to divide both sides by a. And we get that x is equal to c over a minus by over a. Okay. And my second example, we're starting off, we have y equals mx plus b. That's a form that you should have seen last year in 7th grade. That is slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. So we want to solve this for m, which is our slope. So the first thing we do, we subtract b from both sides. You get y minus b is equal to mx. Still trying to get m by itself, so we divide both sides by x. And we do that for everything. So it's y over x minus b over x, and that's going to equal to m, our slope. Now, we're going to use these literal equations, and we're going to apply them and figure out what's going on in this given situation. So the total amount of money that Kishi spends on pizza for a party is T equals 13.49C plus 15.49P. T represents the total amount of money she spends, C represents the number of cheese pizzas she buys, and P represents the number of pepperoni pizzas she buys. Solve the equation for C. So the first thing I'm going to do here, I'm going to rewrite my equation just so that I have it right nearby to work with. So T equals 1349C plus 1549P. Now, I want to solve this for C. So we're solving it for C right there. My first step, we've got our dividing line. We're going to subtract 1549P. So in actuality, what we're doing here is we're saying the total minus the amount that she spends on pepperoni pizzas is equal to the amount that she's spending on cheese pizzas. Now, my final step is going to be divide everything by 1349. Divide by 1349. And we're going to get T minus 1549P over 1349 is equal to C. So if you had been reading ahead a little bit, you'll see that letter B says if Kishi has $85 to spend on pizza and she needs to buy 3 pepperoni pizzas, find the maximum number of cheese pizzas that she can buy. So we're going to take that equation and we're going to move it over to here. And we're going to substitute in the two pieces of information we're given, which is that we have $85 to spend and there are 3 pepperoni pizzas being bought. So we substitute in 85 for the total minus 15.49 times the 3 pizzas that we're buying that are pepperoni over 13.49, and that's going to be equal to our cheese pizzas. So first step, we are going to do that multiplication. So we get 85 minus 1549 times 3 is going to be 46.47 over 13.49. That's equal to C. And now we're doing the subtraction in the numerator. 85 minus 46.47, we get 38.53 over 13.49 equals C. And finally, we do our division, and we're going to get 2.86 is equal to C. So based on that amount, you could buy 2.86 pizzas. Well, can you go to World Famous or Giordano's or Rosati's and order 0.86 of a pizza? I don't think you can. So that limits us. We are only going to be able to get 2 cheese pizzas. That's your solution for this one, because obviously they're not going to give you free pizza if you're not going to be able to just pay like part of it and they'll be like, yeah, sure, here you go, have the pizza. Right? So we needed to round this one down because of that fact. All right. So the you try problem is on the next page. I want you to go ahead and do that on your own. Okay. So Ella makes a video game that becomes very popular. She creates a formula, P equals 40C minus 300, to model her profit, P, given the number of copies sold, C, and taking into account the $300 fee that she has paid a retailer to sell her game. Rewrite this equation to model how many copies must be sold to yield a specific amount of profit. So profit is equal to 40 times the number of copies minus the 300 advertising or stocking fee. So the first step we do, we're solving for number of copies. So we're going to start by adding 300 to both sides. So this would be like taking away the cost she has to have. So profit plus 300 is going to be equal to 40C. Now we're going to divide both sides by 40, and we get profit plus 300 over 40 is equal to C. Now, our next question is that in order to make a profit of $1,900 to fund a vacation, how many copies of Ella's game does she needs to sell? So we're going to substitute in what we know now, which is $1,900 is profit. So 1,900 plus the 300 of the marketing over 40 is equal to C. My first step, combine 1,900 and 300, and that's 2,200. We have 2,200 over 40 is equal to C. And our final step is to do the division. 2,200 divided by 40 is going to give me 55 is equal to C. And our units here are copies. So if she wanted to make the $1,900 to pay for her vacation, she just needs to sell 55 copies of this game, and then she'll be a success. That's the end of our notes for today. If you have any questions after working on your homework, please bring them to class tomorrow. Have a great day.